All right, so here we go to our next talk, remembering that today we're going to have two talks and a panel in the very end, and both speakers will come back in the panel to the panel in the end. Our next talk is business analytics and supply chain management. Dr. Edgar Gutiérrez is a postdoctoral research associate at the MIT CTL, the Center for Transportation and Logistics, in the Omnichannel Distribution Strategies Lab. And he has been an affiliate since 2009 at the MIT Center for Latin American Logistics Innovation, also called CLI. Edgar's research interests are data and model-driven decision support systems in supply chain. Edgar, please take it away.
Thank you, Yuri. Thank you, Yuri, and all the ILP team for the invitation. I'm very honored to be here with all of you. And hello, everyone, wherever you are. Hopefully, you will enjoy this part of the talk. We will go a little bit more in the details of analytics and in the supply chain. This is our agenda for today. We'll go first and talk a little bit about supply chain analytics in the retail industry. We will see then some business analytics into practice and examples. Then we'll go over something that I call hybrid modeling analytics and where it's about and a specific example. And then we'll go over our main takeaways and questions. Right, so everything, when we are seeing how this evolution of customers buying anytime, anywhere, and in any device, right? And then brings a lot of pressure and for everyone, right? Because they have to do it. But this is increasing. This is the online retail represents around 19% worldwide. This is how the communication you see on the right, they will be increased as well in every part of the world. China is leading in this part and 13% in USA. All right, so let me talk a little bit about history. It was 2013. UPS and FedEx, they have this news, December 25th. There was a lot of pressure. There is no gift for kids. They were centered behind, and they seek ways to manage massive peak season package. Albertus is still doing it, but it doesn't finish there. In 2016, Amazon announced they will be open 2,000 grocery stores. So that opened the alarms from everyone. So here in 2017 was the final announcement. That was the big retailer that bought 465 stores. That was in 2017. And almost at the same time, the biggest competitor of Amazon, Walmart, they are saying that they are opening an incubator that will be focused on technology like machine learning, artificial intelligence, and something we'll call analytics. So this is how they are reacting. They are reacting in terms of this kind of technology. Let's see the business goals. We have to increase sales, market share, and customer loyalty. So retention, because everyone wants our customer. We want to improve the ability to rebalance inventory across facilities so we can have better agility. We can go over customer. And we're going to see here, more than 66% of supply chain executives, they are investing in supply chain visibility and mapping. I'm pretty sure most of you are working in this part. All right, so we'll see what is in the yellow part. Now let's go what is going behind the scenes. So to meet all online customers' demands, we need a dynamic fulfillment, an optimal fulfillment location and options, and then we'll have the delivery, right? But there is no ends there. Besides to have all the dynamic fulfillment, optimal fulfillment location and options, we have the returns. And then the returns, there will be another work. There is a lot of decisions that we have to take here. And this will be our talk today. I will talk about this mostly, these three parts. And it's going to spend almost the last 10 years in my life, 12 years. All right. So what it takes to build leading supply chain operations, how they are doing, how all big retailers, people that are doing it. So it seems this is the answer, whatever it takes. So this is the CFO from Macy's. Done one of the quotes. We are providing customers with seamless experience, no matter how they choose to shop with us. And we have the CEO from Amazon, or this another famous quote. No, you make your customer happy in the physical world. They may each tell 6 friends, but on the internet, they can say thousands. All right, so with that, we will focus on the left side that we see in the blue part, that is the dynamic fulfillment. So they are doing this. If traditionally doing maybe from stores or from fulfillment centers, but now we have more options. We have dark stores, warerooms, micro fulfillment centers, lockers. We have click and collect. So there is around a lot of options just to bring to my customer a better service. And what are the trends? We are seeing drones, helicopters, self-driving vehicles, you name it. But how they are taking these decisions? Because that requires time and money, right? How they are doing it. Let's see what is behind the scenes. So if we want to bring analytics to this, we have to bring, obviously, technology and knowledge. Let's see how they're doing. So first part, I will be here a little descriptive and academic. We have to go over the maturity of analytics. This is how mature is my organization in this part. So most of us, we want to know what happened, what did it happen, what is the problem, how many, when, who. All this part is what we call descriptive analytics. And most of the organization already are very good in this. So we are good with the descriptive. We are very good with dashboard. We're very good analyzing what happened, describing what happened. Once I have this, another questions start to come up. The prediction. What and when is something going to happen? What are the trends? What could it happen? What actions can we take? And then we start saying, okay, what is my next step? What I have to do? And take decisions here that are balancing between experience and tools. So depending how mature is the organization and how we take decisions here, depending on their prediction. But the most important, I think, is the prescriptive analytics. What do we do about it? What is the best thing to do? And how will we manage uncertainty, right? So once I have the different scenarios, I have to choose one. I have to manage all those different uncertainties in each one of those, but I have to act. So this is what we'll talk today, and I will go over some of the examples and see how we can see the interactions between descriptive, predictive, and prescriptive analytics and how they help to each other. So how to answer those answers? With that, analytics. And in the world of analytics, let's say there is two big communities. There are the operations research and the artificial intelligence. There is still some dividing where is artificial intelligence is operations research is there. So there's a lot, but so far this is one that is most common from the academic world and the corporation world. So with these two, we can have synergies. We are using operations research with all the statistics, simulation, mathematical programming, multi-criteria decision making, and artificial intelligence. We are seeing they are very famous now. Machine learning, natural language processing, and obviously robotics. This is obviously my toolbar. It is what I have. If I need to solve any of those questions before, this is what I will do. All right, so this is report from McKinsey. They are sizing the potential of the use of analytics. And for that, they went over 400 use cases, 19 industries, and 9 business functions. As you can see here, the retail industry is leading. And here we have transportation and logistics, right? So there are, you see a bunch of different industries doing this, but this is where there's the major impact, right? So you have the impact of analytics here and you have the impact in billing. So it is working. That is proof. That is the way how to do it. But now let's see about data. Now we talk about technology. What are the different tools? I have my operation research, artificial intelligence. I have the different techniques. But let's talk about data. So in data, here we have volume and velocity in this axis, and then we have here structured data and unstructured data. Let's say for now, structured data is everything with numbers, everything that I get with numbers. And structured data, there are text, images, videos that we coming up a lot for all the sensors. So how it looks like is this. We have a lot of data coming up, and we have to handle that data, right? We have to see what we'll do. In terms of maturity, remember that we talk about in the descriptive, so we are very good here in the structured data. My demand forecast, what it will do with transportation cost, now our ERP, but if we go to the right, the things get more interesting. But it's not enough. It's not enough the volume and velocity and the variety. We have another piece. We have veracity, so how accurate is my data, and we have the value. Because it's important. If it's not accurate, so it's not working. But also it should be value data. All right, cool. So now we have this in my in our decisions. We have these three. But now let's go a little bit more deep in the retail supply chain. And this is a very classical view on how we divide it and how people make decisions. There are this strategic planning. There are decisions that take years and a lot of investment, like network design, right? How many, what type, and where facilities should operate. The tactical planning, this is more inventory control, positioning and visibility, and there are decisions that have to take months or weeks. And then we have the operational and executional planning. There are decisions that I have to take daily, sometimes in hours or minutes, like the transportation and delivery, everything we're doing with warehouse, in our warehouse. So as you can see here, there is a very dynamic environment. We are always taking decisions, even if it's for years or it's for months or days. So there is a lot of things to do. So when we have that, we can go and see how we can take over decisions over these three different levels, but it's not enough. We have to take decisions that cover multi-product, multi-period, multi-channels. They should be adaptation and alignment. They should be scalable and resilient, and they should be agile, as we just say. So, wow, there is a lot of things to do, and we have to manage that complexity. So 2 weeks ago, this is this report from McKinsey as well, and it's talking about what are the implications in time and money. Maybe a lot of you are asking, okay, so how long this can take, and how well, this can be expensive. So I recommend this one. And they're saying, okay, there are 5 priorities that we should focus: demand planning, sales and operation planning, control tower, detailed scheduling, and inventory optimization. Today, we will touch these 4 and 5, detailed scheduling and inventory optimization. What does it say about the time? Well, for complex supply chains like pharmaceuticals, typically they can spend 4 to 6 years for full implementation of, or the analytical team, technology people. It is around 4 to 6 years. For retailers and CPGs, they can spend around 2 to 3 years. And probably most of you have been in this experience. So it takes time and patience and a lot of work, but it's worth it, as we saw before. All right, so now let's talk about data, technology, and talent, and how to handle uncertainty. How we start, join all of this, how we synchronize all of this part. So this is the journey. First, we have the reality, and that reality, they are bringing me a lot of data. You guys can see that we get a lot of data from all these different sources and sensors and IoT, etc. So they have here, I'm doing my descriptive analytics. Then I run some models, and then I can do predictions, scenarios, and plans. And after I do this, I have to get a consensus. So people have to take those models and they see if it makes sense or no, and they make a consensus. And then after, I will do my execution, and with that execution, I do a feedback. But for today, we will see how we can go from one place to another. Data becomes information, information into knowledge, knowledge into wisdom, and wisdom into action. And then we are ready to act. That is how we will do today. I will go over predictions, scenarios, and plans, and how people are trying to use different techniques in each one. So let's start with predictions. For predictions, I'm trying to identify, after I get my data and I run my models, I try to identify patterns and how to predict what is happening. And for that, I'm using statistics, machine learning, right? And we will see now a lot of different cool applications, how they'll do it and how they can predict what can happen and how they understand different behaviors. So once I get the decisions, I'd say, okay, this is the prediction, let's act or no, and I go over the execution. So I can review large volumes of data and identify those patterns and trends. I can do conversion of information into knowledge, and also can view customer behavior and business operational patterns. That is the power of machine learning. That is the power of statistics. That is now that we have the data, because the problem is before we didn't have the data. Let's see, 20, 30 years ago, that was the techniques, but then all the data. And then we have a lot of data, and now we are running with time and using all these cool techniques. Let me show you a couple of examples that I did. Here is our customer sentiment analysis. There is one of the techniques for supply chain, the natural language processing, artificial intelligence, to understand the sentiment of people. So there are a lot of retailers that are using for customer sentiment analysis. There was a project joined with another university. There is other colleagues from another American university. You can find the details here. So I can understand how my customer is perceiving my products, my services through their text. They make messages, they tweet, they put some, they rate, they do opinions, and I can see with that, I can take decisions, and I can have almost immediately feedback for hundreds, sometimes from thousands at the same time. This is one. This is a lot of work over there with text mining using in retail. Another one is to understand nature behavior. On the left, we're understanding the humans. On the right, we are trying to see how the weather affect the traffic. And with that, we can plan our deliveries. So this is another cool project that we did last year that was presented here at MIT as well with another colleagues. We're doing all the traffic count prediction based on weather. So we go over, depending the location. If let's say we are in Manhattan. So what happened in Manhattan is raining, it's having sun, and how the traffic will behave. So these two. Now let's jump to scenarios. Let's say that I don't want to see what are the patterns, but I'm more interested to see what are the different scenarios if I change some parameters in my system. This here, and I run simulation. So this is the simulation process. There is a lot of tools in simulation. There is a agent-based simulation, discrete simulation, dynamic simulation. There are, you name it. So once I have this, I can identify and analyze root causes or bottlenecks. I can go with a lot of what-if questions and scenarios without having to experiment in the real system. This is one of the powerful tools. I don't have to go there and buy a new warehouse or to buy a new conveyor. I see how it looks like. Analyze and kind of analyze the impact of decisions. I have a couple of examples as well here. On the left, there is something that we are working here on the lab with Dr. Eva Ponce, who is the director. This is with a big retailer in the United States. We are simulating how will be the implementation of reusable packaging in the system. So when we start seeing, okay, what are the implications? If I will circulate the result package, what do you have to do? And then the simulation part, the simulation tool was perfect for this. And that will be presented in mostly in 1-2 months in the PUMPS conference. And we go over this. So we simulate each step for the package. Another cool project was in maritime logistics. In this case, they already have plans to buy new vessels. There was also a company for the oil industry, and they are doing all this maritime logistics with different ports here. So they have the motor tank, and they have the different vessels rolling out. They already have what they will buy and how will they do it. So they want to run different scenarios and the number of vessels, how they do it. They already run an optimization model, and they want to prove that optimization model with simulation. So that is the powerful optimization, that you can change all those scenarios. And then we have plans, how I find my optimal plan. That's where I use applied optimization, mathematical programming, and I can identify what is the best plan under current and forecast circumstances, how can improve strategic, tactical, and operational decisions, and how I can manage complexity and dimensionality for multiple possible scenarios. And here we also did a couple of examples. One that is one of my favorites was with the optimal fulfillment location options, this one. So we are working in a model and how to do all inventory positioning over those dark stores, warerooms, fulfillment centers, how I can do it, and how we will try to deliver on time and have a seamless experience for my customer. This is one project that we're doing. And this other that we did last year was most about vehicle routing and last mile deliveries, that I will spend the last minutes of this talk, and I will go in detail with this one. All right, so we have machine learning, simulation, and optimization. But what is the best method? We will say, okay, we have those three. Now, what do you have to use? So as I said before, depending on the maturity of the organization, there are some organizations that use one more than other. Also depends of the technology, the knowledge, and also depends what they like it. You know, the CEO, they have a lot. Well, if I mentioned at the beginning, the supply chain in the parts of fulfillment and delivery is what I have been working. But this is my research, how to do hybrid modeling. This is what I'm doing as a researcher. So we are trying to combine those three techniques in order to handle variability and uncertainties. There is obviously no hidden in our team. There's a lot of people working in this, and this is the leading edge. Let's say this is the frontier on the research. They're trying to combine the pros from each of the techniques and trying to make the decisions. But again, we have here the team consensus and how we execute and take the data. All right, so this is I think what we have. Now let's see how I have to do alignment. I have to do alignment between my business model, my data scientists, my research development IT with over those three techniques or methods, and then I will have my analytical models. So you will probably be asking, okay, so we have this, we know the methods, but how is the implementation? For example, you already have experience, probably know, but let's see, I'm trying to bring how will be the implementation of this. Let's say that I have to understand very well the business requirement, right? I have to understand business requirements, customer requirements, how is the environment, and most of the times this is in the sales and operation planning. I have here or people from different divisions in my company, right? I have people from logistics, marketing, finance. There's a cross-functional team when I'm trying to figure out all those requirements. So that I put in my ERP, and also I bring the WMS because I love inventory and will be one of the examples. So I bring the WMS and the ERP data, and then I start doing all that data consolidation. Once I have that, I have to spend a lot of time and trying to figure out verifying what I need, what I don't need. I'm making a lot of data message in terms of have data ready for my models. All right, so from here to here, there is a lot of interaction. So I have people from the company that doesn't have to do anything with technology, and I have all here people that are working with more technology and models. And here is a lot of time and negotiations, and there is something that is called translator. Now there are data scientist translators that are trying to figure out how to talk with these two, and there are months probably to go from here to here. Obviously, when I have this and I have the approval and I have that feedback loop that we see before, so I have all the control tower dashboards. And this, let's say, this framework is what we call a decision support system, right? So we have our people, our technology, the data, and the decision. All right, so this is how it looks like. If we put over the data, the knowledge, the information, the wisdom, where it goes in this decision support system. The data is here, our environment, right? We are bringing all this information that I belong in the patterns or predictions. I have my knowledge with the people in my organization, plus our models. I have the wisdom here, how to combine all of them. And finally, I have to take the action. So retailers have been implementing this decision support system for many years, but now they are bringing all these different technologies in terms of to see how they can use one and the other, how they can combine and synchronize that point. And that what we call hybrid modeling analytics. But we'll start wrapping up our presentation. So the moment of truth, and I choose between the dynamic fulfillment and all the locations and the delivery, and say, let's see, when we touch the customer, right, during the delivery. So let's see how we use this combined, and there is a lot of complexities how we do it, and we'll see, and we all of us we are living this. So this is a hybrid modeling for urban last mile delivery. So we are trying to go from the physical world to a digital world. So there are also some people that have, and there are a lot of researchers in academia or corporation that also can call this or name this as a digital twin. I'm taking my physical world and making my a digital representation. So we'll go over this very quick in these last minutes that we have, and we'll see how we combine all this with hybrid model. So we'll see, we already know. Now everything is increasing, total deliveries, 28, grocery deliveries, more than 100, delivery vehicles, more than 36 by 2030. So there is something that is still there, and we have to live with that. So most of us, well, when we are seeing the deliveries, we say, okay, definitely we have to go over the traffic, right? How I get my ATA, my estimated time of arrival. So let's see if I know the day of the day, hour, I see the weather, I see the infrastructure. So I can have, a good sense of my ATA. But most of the time, it's not enough. It's something happened because I have the plan, and when I go and do the execution, it is difference. There are difference between my plan and my execution. So now people are trying to figure out what it is. And then start bringing connection in between the strategic, the tactical and operational plans, and the execution. And for the execution, I have to understand behaviors, the behavior of my customer, the behavior of my driver, the behavior or the traffic, the location, and now I have this. The estimated time of arrival. I have to deal with all of that. And I have my travel time. Now it's not just depending on traffic, but it's also depending on the location and what happens in the location. Density, parking zone, the topology, the geography. The driver, how expert is my driver? It is new, it's his first day. We know. We have to understand the driver. And the customer behavior, where he's living in a building, in a house, in a townhouse. So here, between the travel time and the service time, I can plan for everyone. So one tool from those that we saw before wasn't enough to solve this problem. So there was a company that called us. This is an improvement and retail store that work with appliances and construction materials. They have thousands of SKUs, hundreds of daily deliveries, and they have presence in 7 countries. This is the team. There are some colleagues from national and international universities. Then we call and say, okay, how we solve this and what we do. So remember when I show you how the hybrid modeling? So this is the methodology for this specific case for deliveries. So we have my historical data for traffic, customers, drivers, etc. I have all my data mining methods where I'm trying to understand patterns, recognition, profile definitions, and then I have here machine learning and optimization algorithms to solve the route and the schedule. That is the important part to do the deliveries. And when I finish, I have all my feedback process that feed my data to start again to do that. So that was the methodology that we proposed, and then went. And this is the case study. So this is a city, 12 million population. We start collecting data. We collect data with the surface, the population, the density in the divisions that we have. So first thing, divide and conquer. So we divide the city and we identify this part. It wasn't enough? No, because we have this kind of infrastructure, as you see in these pictures. We have small streets, big streets, we have heights. So velocity change as well. So we have to go and check what is the velocity in each of those different locations, in all different districts. We get the demand, we have the type of vehicles that we need. That was this step 1 and 2 that we saw in our methodology. So we have our that data, so we start doing clusters, definition, and customer information, right? So we get the clusters for each of that part, and on the right with different colors, we have our clusters to attend that. We did optimization models that can bring us how I can choose from many different vehicles with different capacity. These are also classical problem that most of the logistics that you have. It is different vehicles, different capacity. What is the best? How I minimize that? So here we use optimization, having constraints in weight, volume, and obviously in time. Once we have our optimal vehicles, we'll say, okay, now let's simulate this, how it will behave. Let's see if this work or not. But before to have a new fleet of vehicles, we can simulate it, right? So we have to simulate it. How? We have to go understand, again, the city, the driver, the customer. So I bring here the behavior of the city here and how they combine with the driver. So it is one of the locations. Let's say we choose one. And for that one, I have the velocity depending on the time of the day. So it go and then go from 16 for 10 miles per hour to 24 miles per hour. And I have here my driver. When the driver arrives for the customer, they have to search for parking, they do the deliver, and they have to go again for the next customer. So I'm bringing that data, I'm capturing all those times with my simulation model. You wanted to how it looks like. Now I have the optimization, the simulation, and then I have a visual representation of those different places that there is these different zones, and there is how the vehicles go and make decisions. We can see here the routes. So, and then we combine those different tools. We have the optimization for number of vehicles, optimization and machine learning for routes and clusters, simulation with agent-based simulation for the delivery schedule, and we have to learn, right, from execution. What does it mean learn? So remember that we call all of these agents. So we have our agents that are taking action in a simulated environment where we'll do the proof, and in a real environment where they do the execution, and we start learn about the city, learn about what happened with those scenarios. So with that, we start improving our routes with the machine learning techniques. We use something that's called deep reinforcement learning to detect how the city behave and to have a very schedule per vehicle and per day. So they have here all my vehicles. I know what are the customers, the average service time, at what time it arrives, at what time they go, and that improves my accuracy in my promise. If I have the arrival time and departure time, so I have to plan for hundreds of customers. All right, so let's see some managerial results from this. The execution of this methodology was capable of solving this complex problem. We reduced the number of vehicles utilizing in 20% from the methodology that they have. They were using just optimization models. So when we bring this and we bring this new data and information and the machine learning techniques, combine it with optimization, we're capable to reduce the vehicles. Obviously, that reduces cost. We increase the resource capacity utilization that were very balanced. The methodology proves to be effective despite being all this data demanding, because not just we take data from all the execution, but we simulate a lot. We take a lot of data from the simulations. It aims to transportation manager supports peak and valley delivery. Obviously, we bring the methodology to create the decision support system. All right, so main takeaways for my talk. Let's talk about business analytics. First, there is a lot of data challenges. This is fun times here. A lot of people like this part. When you have to search, capture, sharing, and storage, I have all my data sources, all the process. I have all my analytics tools, and then I will have my enterprise optimization. This first part is where I would call the analytics process, and the right part we call the business intelligence. Second part of the main takeaways, hybrid modeling helps to integrate areas of the supply chain, avoiding those silos among operations, and that brings competitive advantage. Supply chain is sensitive to changes in demand, socio-demographic factors, location of demand, as we saw. Challenges like network design and inventory positioning needs a tailored modeling approach. Is depending of the different business strategies that you have. So it's difficult to bring on a shelf tool and just plug it in and do it. So we need a more tailoring model approach. Design supply chain networks help all stakeholders to gain end-to-end visibility control. All right, so for all of the examples, I bring the sources that there are public, there are free. So if any of the examples you like, you can go there. There's a couple of books where you can find more about this hybrid modeling. And remember, evolve or perish. Thank you very much, Yuri. Thank you very much, Pia. Thank you, everyone, for this time.
Thank you, Edgar. Thank you. Perfect timing. And again, you guys from the CTL are pretty excited about, when you talk. Thank you so much. Let's go in the same way that happened to Chris. I don't think we're gonna have time to all the questions that we have here. So let's go straight to the questions. Being the first one, this question: what's the advantage to have an in-house analytics experts and data scientists versus consultants or academic researchers to leverage off-the-shelf modeling platforms?
I love that question. And we get a lot of time that question because the tendency for multinationals, for big companies, is to have an in-house team, an in-house data team. And as we saw in the presentation, we need data, technology, and people. But we also need that it should be sustainable. So we have the two spectrum. We do totally in-house, we have totally outsourced, but we also have a mixed. We have sometimes there is some people in-house and some people is out. So one, depends of the size of the company, if they can make a team sustainable over time and in-house, the knowledge and the maturity of all these data analytics. The good thing with academia is there are people that have been working in the frontier of research. They already run the miles, with all of these different techniques. They already run a lot of experiments. They have also a lot of trial and error, as is in science, right? And they can have a good advice. So yeah, so that is, with that, I'll close my answer.
Okay, let's go for a very specific one, Edgar. What kind of software do you use for machine learning, simulation, and math optimization?
Wonderful, wonderful. I like that question as well, because it's how I bring this to reality.
Yeah.
Oh, you told us all this, but now I want to do it. That I love it. That there's people that I really want to love to do it. All right, for machine learning, there are more coding programming. We have the algorithms probably, and the methods probably like more than 30, 40 years ago. But now there are different tools like Python, C++, Java, that we can bring this, and they will have a good experience between the amount of data and my algorithms. So this is from the machine learning view. And the other good thing is they are free. So probably they were asking, okay, but how it costs? So they are free as well, Python or Java. From simulation, well, it depends of what kind of simulation. We have 3 different simulations, but now one that is very used in academia is one that is called Simio, that is called AnyLogic, but we have also classical simulation houses, that is Promoter or Arena. And for optimization, well, the optimization, that is my first and true love, because now I'm in hybrid modeling, but my first one and my background is OR. So they start with the solvers, and the solver is that brain that have the algorithms to solve a problem. Well, now there are 2 leading edge solvers. One is Cplex, and there is Groby. There are also MIT babies as well that they are niche here. But there are others that there are more on the commercial part, but there are another bunch of software that also it is free. Pyomo, PLG, GLP. There is a bunch. Just to wrap up the answer, you can find software for any of the tools that we see. There are free, and others that are more commercial, depending.
Thanks for the list. I hope who asked took notes. Edgar, next question. What's the role of blockchain in a more efficient and secure supply chain?
Great question. So we have the blockchain. We are bringing security. We are bringing transparency in all the data. As you see, all of those models that are data demanding, mostly all the machine learning, and then I have IT transaction all over on my supply chain, right? I have to go over all this data because there are data that coming in. There are data that I create. That is in the data, I create historical data that we bring it, but also we have that data that is design data. And we have to make sure we don't miss that part. So in terms of security, in terms of agility, in terms of transparency, blockchain is taking a lot of space in supply chain and obviously in all the supply chain decision making.
All right, excellent. Next question. For multi-echelon supply chains, 3 or more tiers, how do you get the data to populate the analytical models?
Great question as well. So sometimes we don't know what happened after my next echelon, right? We don't know what is going there. So most of the time, I've been seeing this in practitioners and in academia. When we bring the simulation. If I don't know what are the data from there, I have to bring the data simulated, and I have to be very accurate with what are the tendencies, what are they doing, and then I have to come up with a solution that can bring me data for those analytical models. And also that bring me a very short here. Machine learning needs a lot of data because I'm seeing what are the patterns over there, what is the behavior. But optimization models, the analytical models, I'm bringing the structure of the problem, that you have the equations on the optimization. And that's why we are trying to combine these two. Now we bring the simulation to bring more data and it can generate more. That is what we did in the urban logistics problem.
Okay, this may be your next question, given the time, which is a perfect world does not exist in supply chain, but how far can we go with intensive analytics data, or better to say, how close to the perfect world can we be?
Well, the accuracy in our decisions. That's why we never, so far, let's say, so far, it is difficult to have 100 full automation when they go and they decide everything. As you see, we have to go over a consensus. There is the human, the knowledge of the human, and see what are the model is doing, the model representation from reality, and if they make sense to go over those answers. And I think is the best way to do it, because when we have the machine, we have the models, we are increasing in accuracy in what we're doing. We are increasing in efficiency of how we'll do it. But definitely there is always managers, people with experience that go over those results and make that all the magic happen. People, we can avoid people. People also always should be there.
Phenomenal, Edgar. Thank you so very much. So again, the same thing. We have like 3 or 4 questions. Unfortunately, you won't have time to answer those. Thank you very much. And I see you back in the panel in a few minutes, a couple minutes.
Wonderful.
Thank you.